This is the review for the first portion of the Unit 4 exam. This is going to go over naming compounds, both ionic and covalent, and we'll do some balancing of formula equations. This is a general flow chart to kind of assist you when deciding how to name some of these simple compounds. If you want to go ahead and pause the video, copy this down in case you don't have this information, go ahead and do so at this time. This first compound could be a little tricky. The reason for this, you'll notice that the first element isn't really a metal or a non-metal. It's a metalloid, arsenic. The way we're going to treat metalloids, we will name them as if they are non-metallic. So we will use the prefix system. And so you'll notice there are 2 arsenics and 3 oxygens. Therefore, this is diarsenic. Trioxide. This compound is definitely an ionic compound. You have nickel, a metal, and then you have a polyatomic anion, nitrate. The thing you will notice is that nickel is a transition metal, so we need to use a Roman numeral to explain the charge that nickel has in this instance. What I'm going to do is I'm going to unzip this formula. Okay, there's an understood 1 that goes up here. Nitrate is 1 minus, so we're good with that. Nickel in this instance is 2 plus. And so the name of this compound is nickel 2 nitrate. In looking at this compound, you will notice there are 2 nonmetals, so therefore I'm going to use the prefix system. You never use mono with the first one, so this is simply carbon Die Sulfide. Anytime you have an element as the anion, it ends with IDE. This is another example of a molecular compound, 2 nonmetals, prefixes once again, dinitrogen, name the first one just as the element, and then pentoxide. Okay, this compound, once again, is an ionic one. You have a metal and a polyatomic anion. The metal, once again, is a transition metal, so we must use a Roman numeral to indicate the charge of copper in this instance. So if I go ahead and I unzip this, copper comes up here. This is the polyatomic anion sulfate. Okay, there's an understood 1 that goes here, and then there's a 1 that comes up here. Notice the 4 does not move. Okay, that 4 is part of sulfate. So this 4 does not come up here. There is a 1, an understood 1 that goes there. Now the first thing you're going to notice is that sulfate here has a charge of -1. That isn't the charge of sulfate. Sulfate is -2. So what does that entail? Well, that means we have to change this to -2. If we double that one, we must double the charge of the cation. So copper in this instance is copper 2. So the name of this compound is copper 2 sulfate. Here's another compound containing a metalloid. We will go ahead and name this as if it were a non-metallic element. And so silicon tetrabromide. This compound has a metal and a non-metal. Potassium is metallic. Because potassium is a representative charge, it's in group 1, it's always 1 plus. All you have to do is just simply name this one potassium chloride. This is another ionic compound, magnesium, and then you have the polyatomic anion nitrite. Because magnesium is representative, it's a member of group 2, it always has a 2+ charge. Therefore, I don't need to mention this 2, because the only ratio in which these two things combine is in a 1:2 ratio. This is 2+, each nitrite is 1-, so it takes 2 of them to balance the charge of magnesium. So therefore, when you name this compound, this is magnesium nitrite. This is a similar problem to number 5. Once again, we have a metal and a polyatomic anion. If we unzip this, because lead has various oxidation states, so I'm going to put lead up there, I'm going to put sulfite up there. There's an understood 1. It goes there, and the 1 goes here. -1 is not the charge of sulfite, it's -2. If you double the anion, you must double the cation, so lead's charge is 2+. This is lead 2 sulfite. You may be tricked by this one. You may say, oh, this is easy, this is sulfite once again. But here's the deal. Sulfite is a polyatomic anion. This lacks a charge. There's no charge present. So this is not a polyatomic anion. This is a molecular compound because there are no metals present. There's no charge. So we have to name this as if it were just like any of the other covalently bonded compounds. There's 1 sulfur, so it is sulfur trioxide. This is another ionic compound. You will notice sodium is the metallic element, has a representative charge. The polyatomic anion is chlorate, so this is simply sodium chlorate.